Good morning, ladies and gentlemen. Today, in this video, we're going to review writing equations of lines. Writing equations of lines in XY land. Note that this is a review from Algebra 1, but certainly a review worth going over. There are two important forms of lines in XY land. Consider the points x sub 1, y sub 1, and the point B, x sub 2, y sub 2. Form number 1, the slope-intercept form. Here, in the slope-intercept form, we have the slope of the line m, which is equal to the change in y over the change in x, the change in y being y sub 2 minus y sub 1, x sub 2 minus x sub 1. This is the formula that you all are very familiar with, but again, worth reviewing. The y-intercept is b, which means the point 0b is on that line. So when I have this slope-intercept form, I'm talking about the slope and the y-intercept when it is in that form. Form number 2 that we most use is called the point-slope form. This is called the point-slope form because we are given a point and the slope in this form. So we're talking about x sub 1, y sub 1, and the slope. And you can see the x sub 1 and y sub 1 here. The point-slope form is used most often in more advanced math classes. But we are going to, in Algebra 1, we will use point-slope form, and that will give us a good way to write a line in slope-intercept form. So let's begin with example 1. Example 1 wants us to write the equation of a line that goes to the point A, 6, 1, and B, 3, negative 1. So the step 1 always, or the step 1 in this example, will be to find the slope. And to use the slope, I'm going to use the slope formula, which is y sub 1, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We have to make sure if we're going to start with one point, the x and y's of that point have to line up. And we can let either point be x sub 1, y sub 1. I'm going to choose B as being x sub 2, y sub 2. So I'm going to let this guy right here be x sub 2, y sub 2. Therefore, the slope then is going to be negative 1 minus 1 over 3 minus 6. So I have y sub 2, which is negative 1, minus y sub 1, which is 1, x sub 2, which is 3, minus x sub 1, which is 6. So negative 1 minus 1 is negative 2. 3 minus 6 is negative 3. Negative divided by negative makes positive, so our slope of this line is 2/3. Step 2 is I'm going to write point-slope form. I can use any point I want. I am going to stick with, this time, x sub 1, y sub 1. I let this be x sub 1, y sub 1. And I'm going to use that in point-slope form. So point-slope form is going to be y minus y sub 1, which is 1, which is equal to m, which is the slope, times x minus 6, which is x sub 1. So here we see this is the slope, this is y sub 1, and this is x sub 1. What I'm going to do now is I'm simply going to do a little bit of algebra, and I'm going to solve for slope-intercept form. I'm going to solve for 1. Or pardon me, I'm going to solve for y. The first thing I'm going to do is I'm going to distribute that 2/3. So if I distribute that 2/3, I have 2/3 x minus 2/3 times 6. 2/3 times 6, we see that 6 is 2 times 3. These 3's will cancel, and this 2/3 times 6 becomes 4. Writing that extra step out. Some of you will not need that extra step. And all I'm left with doing now is to adding the 1 to both sides, and so y is equal to 2/3 x. And if I'm adding 1 to both sides, again, writing the steps for you, minus 3. And I'm going to make that in blue. So now I have the slope-intercept form. Here the slope is 2/3. We knew that. And the y-intercept is -3. Let's go to our next example. Our next example here so write the equation, the line in slope-intercept form that has slope of 1/3 and has y-intercept of -65. This example is going to be very easy because I'm already given the slope and I'm already given the y-intercept. So I'm simply going to go right to the slope-intercept form and put those values in. Y is going to be 1/3 x minus 65. And if I were going to graph that line, and we're going to be doing a lot of graphs of lines, graphing lines, I'm just going to estimate some things here. I'm going to estimate this y-intercept. This y-intercept is going to be down here, somewhere at 0, -65. And I know that the slope of that line is up 1/3. So the incline of that is not very steep. And I'm going to see if I can't grab a line in green. I think I can. So it's going to be, approximately, it's going to look something like that, where I'm going to go up 1. The slope says I'm going to go up 1/3, up 1/3, up 1/3. So this is an estimation of the graph, an easy equation to come up with. Let's go to another example. Solve the following equation for y and find the slope and y-intercept. These problems are sometimes can be a bit tricky for students, but I think we can handle it. So I'm just going to rewrite the equation. Keep in mind what I want to do. I want to write this equation in this form. mx plus b. That way I can reach right in and grab the slope and reach right in and grab the y-intercept. So the first thing I'm going to do here, I like to use the borders. This is a good idea to use the borders. I need to get that x on the right side. To get the x on the right side, I'm going to add 5x to both sides. Not 55, 5x. I'm not going to forget this -2y. And I'm going to realize that -2y is equal to 5x plus 24. My next step is I'm going to divide everything by -2. Every term in the equation I'm going to divide by -2. And that's going to leave me y is equal to +5 divided by -2 is -5/2. 24 divided by -2 is going to be -12. And if I graph this, Well, let's pull out the slope first. The slope is going to be negative 5/2, and the y-intercept is going to be negative 12. So I'm going to scale my coordinate grid in units of 2, and I'm going to plot this y-intercept first, 2, 4, 6, 8, 10, 12. And my line goes down 5 over 2, down 5 over 2. I can't see it. I'm out of points over here, but if I went up 5, that would be the same as, I'm going to make a note here, true or false. I believe it's going to be true. Negative 5/2 is the same as negative 10/4. And I know that I'm going to be going downhill. So what I'm going to do, since I can't see the points over here, I'm going to go up and back. And I'm going to go up 10, 2, 4, 6, 8, 10, and over 4. Bam, bam. So this is going to be my other point. And I want to sketch a line through that. And if I started at this point and went this way, I could see that I'm going down 10, 2, 4, 6, 8, 10, and to the right, 2, 4. All I'm going to do now is simply sketch my line through those 2 points. I didn't get a very good line through those points. Maybe that was a little bit better. So that's the line that goes through those 2 points. That's the graph of the line. So I started out with a line that was written in this form. I wrote it in slope-intercept form. I pulled out the slope, and I pulled out the y-intercept, and I used those 2 numbers to graph the line. Let's go through the next example. Find the x and y-intercepts of the given line and use them to graph this line. Well, what I need to do to do this problem is I need to remember that whenever I have any x-intercepts, if I have any x-intercepts, they happen on the x-axis. And what is this common theme of any point that is on the x-axis? All of these points on the x-axis have a y-coordinate that is 0. No matter where that point is, it's going to have a y-coordinate of 0. I'm going to use that to make this problem really easy. I'm also going to use the fact that all y-intercepts have x-coordinates that are 0. So wherever I am on the y-axis, if I'm going to intersect that line, whatever that point is, the x-coordinate is going to be 0 wherever I am. So I'm going to use this fact to make this problem really easy. So the first thing I'm going to do is I'm going to find, let's find the y-intercepts, and let's find the y-intercepts. Let's just let x equal 0. If I let x equal 0, I'm going to have this equation. I'm going to put 0 in for x, and look what do I have. Negative 4 times 0 is 0, and I simply have negative 3y is equal to 12. That says that y is equal to negative 4 dividing by negative 3. And so this is going to be my y-intercept, 0, comma, negative 4. To find my x-intercept, I'm going to remember that y is going to equal 0. And I'm going to put 0 in for y into this equation. Negative 3 times 0 minus 4x is equal to 12. That leaves me that negative 4x is equal to 12. X is equal to negative 3. and that's my x-intercept, -3, 0. I'm simply going to plot now these 2 points, 0, -4, and -3, 0 on my grid below, and sketch that line. This time I'm going to scale my coordinate grid in units of 1 to make it easier. So I have 0, -4, bam, bam, bam. Here's my 0, -4, and -3, 0. I have the 2 points. I have the x-intercept. I have the y-intercept. I'm simply going to sketch that line. This time I will sketch the line in blue. And that's the line. And it would extend this way as well. Fairly straightforward problem. Put some arrows on it to denote that the line goes on forever. My next example here is I'm going to talk about parallel and perpendicular lines. Keep in mind, these are all topics that were covered in Algebra 1, and this is just an Algebra 1 review. It does seem like we're going a little bit fast, and that's okay. So how about some parallel lines? Parallel lines, 2 lines are parallel if they have the same slope, but they have to have different y-intercepts. If they have the same y-intercepts, they're the same line. So if I consider line number 1, y is equal to m sub 1 x plus b sub 1, and line number 2, y equals m sub 2x plus b sub 2. These lines are parallel when the slopes are equal and the y-intercepts are different. That's very important. So example number 5. Write the equation line in slope-intercept form that passes through the point 3, 6 and is parallel to y equals 1/3 x minus 99. We threw that -99 in there to realize that, hey, you know what? You don't need that. Because all you need from this line, if I want parallel to this line, I need this slope. I'm going to use point slope form to start this line off because it is so easy. And I want the equation of the line that passes through this point and is parallel to this. So I'm going to use this point in point slope form, and I'm going to use this slope. So I'm going to go y minus 6 is equal to 1/3 x minus 3. I'm going to solve for y. First thing I'm going to do is distribute like I did before. I have 1/3 x, 1/3 times 3 is 1 minus 1. Add 6 to both sides. And I have 1/3 x plus 5. So this line is parallel to this line. This is the notation for parallel. That means parallel. And I see that they do indeed have the same slope and different y-intercepts. These lines are parallel. This notation, this is our notation for parallel. And let's end with an example about, hey, perpendicular lines. 2 lines are perpendicular if the product of their slopes is -1. So if I consider line number 1, m sub 1 x plus b sub 1, and line number 2, y is equal to m sub 2x plus b sub 2. These guys are perpendicular when their slopes, m sub 1 and m sub 2, the product of their slopes is -1. So let's hit example 6 here. And example 6 says, write the equation of the line in slope-intercept form that passes through, again, 3, 6. But this time we want it perpendicular to this 1/3 x minus 99. First thing I need to do is I need to find the perpendicular slope. I need to find the perpendicular. This is the notation for perpendicular. I need the perpendicular slope to 1/3. So I need to find a number. When I multiply it by 1/3, I get -1. With a little bit of investigation, I think we can see that that number is going to have to be negative. If my product becomes negative, I'm going to have to start with a negative. And what times 1/3 is 1, and that's going to be 3. And what this is just a negative reciprocal of 1/3. This is my perpendicular slope, -3. This is the slope, and what am I going to do? I am going to, yes, again, I'm going to start with point slope form. I'm going to put my point in, and I'm going to put my new slope of -3 in. So let's do that. Y minus 6 is equal to -3 times x minus 3. I have my point 3,6. I have my slope, my perpendicular slope of -3. I'm going to solve for y. -3x. -3 times -3 is plus 9. Add 6. And what do I have? I have this line right here, which is perpendicular to this line. And I think that's a really good review of some basic writing equations of lines from Algebra 1.